All right, the solving part is actually the easiest part of this whole thing. It's really that part that gets really, I don't know, tedious. So when a question says solve, right, and it gives you this, one thing we know about this equation is that it equals 0, right? And when it equals 0, we want to make this statement true. So what's the fun thing about 0? What's anything times 0? Anything. Always going to be 0. All the time, right? That's the beauty and the power of 0. So that's also known as the zero product property. What do we say? Anything times 0 equals 0? In our own terms. Back it up. Brian, can you read that from the back? I can write bigger. That's why. Can you? Is it too small? No, you can read it. Okay. See, it's getting colder now. Okay. So I put that little a times b equals 0 because if a equals 0, would it make that statement true? If b equals 0, it would make that statement true, right? Okay. On to this now. On to this now. This is my a. This whole thing is a. This is b. How do I make this statement equal 0? What does x have to equal? So say it again. So 0 plus 3, does that equal 0? Negative 3. Why negative 3?
Because you're going to add a positive 3 to it.
So then does that equal 0?
Yeah.
Lovely. Okay, there's that way, right? You could just instinctively know, like, all right, if I need to make this equal 0, what plus 3 equals 0? Negative 3, right? Sometimes it could be that easy. What you can also do is, because I'm saying that this needs to equal 0, I could literally write it out as an equation, right? I need this to equal 0. So then in this case, I need this whole equation to equal 0. So then that becomes x plus 3 equals 0. And then how do we get x by itself? Minus 3. And to what Brian said, we end up with x minus 3. Easy peasy, right? That's solving. That's solving that part. Okay. But then we also have the other q value. Brian, what did you get for the other value? What would x have to be? Negative 5. Does everyone agree with that? Yeah? That one's way too easy, huh? Okay. Duly noted. Just for so if this question ever said solve and it gives you two binomials multiplying each other, this would be your answers. x equals negative 3, and x equals negative 5. I can plug any of those into this equation, and that makes the statement true. Okay? Let me know when I can erase. Sorry, that was supposed to be example 1, but my bad.
What do I show?
Can you go after this example? Yeah? It'll be quick. So what about this one? This one's a little tricky because it has a number on the outside, or a variable on the outside. What does this have to be to make this statement true? 1? So if x equaled 1, right, it would be 1 on the outside, and then 1 plus 6 equals 0. What's 1 plus 6? 7. Times 1? So not quite. So what else can it equal? It can equal negative 6. So then if I put negative 6 here, and then negative 6 plus 6 equals 0. What is negative 6 plus 6? Yeah, 0 times negative 6. What's anything times 0? So then that checks out. So x equals negative 6, but it can also equal one more term, variable, number, thing. What about this one? What can that equal to make that whole thing equal 0?
Zero.
Somebody say it with your chest. Say it.
0.
0. I see somebody whispering. All right, so then if 0 and then 0 plus 6 equals 0, yes. Boom. So then answers are x equals negative 6 and x equals 0. That one's the easy one. If you just have just one variable on the outside like that, 0 all the time. Too easy? Everybody getting it? Yeah? I'm going to do example 3. Can I erase this? Yeah. Last time I got yelled at for doing that. Okay, this side of class. Rain Dylan. Do this one for me. This side of the class. Do this one for me. You guys have Brian on your side when he comes back, so I can even it out. 3 and 3, that's solid. Do you guys solve it already? Okay. Well, make sure you check in with each other. You guys can talk to each other. Okay. Dylan, what'd you get? Still working on it. Make sure you check in with him. You guys are working together. Ray, he was looking for you when you weren't here at 11 o'clock on the dot. He goes, "Where's my boy Ray at?" And I told him like maybe he just doesn't want to sit next to you anymore. What'd you guys get? What would make this 0?
Could we use the X method for that?
No, you don't need to. Set it equal to 0, because that whole thing has to equal 0. I gave you the more difficult one.
I know you did.
Good. You're struggling?
Yeah.
Good. You want to ask them for help?
No.
That's crazy.
Not like that.
No, it's okay. You said what you said.
Oh, it's together, bro.
Look, I don't cook very often, but when I do, I'm stirring in that pot. Oh, it's so cringy, huh? You guys are laughing though, whether it's at me or for me. Still laughing. Okay, you ready to go over this? Yeah. Let's start with your side.
I didn't even wrote anything down.
Try it. You want to do it on the whiteboard?
No.
Oh.
No.
Oh. What would you do first? How do I make this equal 0? Write that out. That's just as a statement itself. Like, how do I get that to equal 0?
Can we minus them?
Did you set it up equal to 0 yet? Not yet. So 3x minus 3. Ryan, you have to do this one.
Oh, for sure.
Okay. Remember your notes where we change it to literally equal 0? What did that look like? Like she wants to help you.
I have a question about it. Since
No questions.
no,
Answers only.
okay.
Go ahead.
If it's a positive 3 and a negative 3, if you combine them, that creates 0, correct?
It creates what?
0. Positive 3.
But can you combine them?
Yes.
Are they the same kind of term?
No.
No. You can't combine them.
Get rid of the X.
Hmm?
Get rid of the X.
How do I get rid of that x? Yeah, you do. You do something like that. Brian, you got something for us?
I don't have anything.
So if I set this equal to 0, how do I solve for x? Because now I set the equation, but how do I solve for x?
You solve for X.
It's a good start.
Provide the X.
Huh?
Provide the X.
You can, but that'll be tricky. No, not really. Okay, how about this? How do you get x by itself? Yes. And how do we do that when it has this and this attached to it? How do I get rid of this first?
You add 3.
We add 3, right? Just a regular 3, not a 3x,
No,
right? If I do that, I get this, yes?
Yeah.
That zeroes out. I'm left with a positive 3. Then what do I do?
Now you divide.
Then I divide.
X equals 1.
Bada bing, bada boom.
Isn't X equal to 0?
No, it's supposed to equal 0. Bruh. If I put this into this equation, it'll equal 0. In like 3,
I thought it was supposed to equal 0.
not x equals 0, the equation equals 0. What about the other one? What is it x equal for this to equal 0? Also 1.